Can you hear me? Hello? मेरी आवाज आ रही है?
Yes, sir.
ओके, ये बीच में कनेक्ट डिस्कनेक्ट हो गया था, मैंने वापस जोड़ दिया तो सो लेट्स कंटिन्यू वेयर वी लेफ्ट। लेकिन हमने चलो थ्योरम कंप्लीट हो गया था जब हमने वो जब ये कट गया, वो अच्छी बात है। तो हमने देखा कि अगर f is continuous on a closed bounded interval, then f is bounded there। यानी कहने का मतलब then there must exist some m and n such that f of x जो है it is less than or equal to this m and greater than or equal to this small m for all x belonging to AB। अगर f continuous है तो this must be true। तो वही हमने प्रूव किया। अब नेक्स्ट थ्योरम ये कहता है कि नहीं, उतना ही नहीं होगा, there would be some number, यानी जो m और m है जो इसके lower and upper bounds हैं, then there must be some numbers here alpha beta belonging to AB, and it must assume its bounds, यानी जो bound है they should also be in the range of the function for some values in the domain, and there should exist, जो हम prove करेंगे कि alpha beta such that f of alpha is equal to some this small m, the lower bound, and f of beta is equal to the upper bound। So that's our next theorem, जिसको मैं state करूंगा। ये उसी का actually एक तरह से continuation है। If a function is continuous, f from a to p to r is continuous, it is continuous at every point of this interval, then it attains its bounds। ये तो हमें पता ही ये bounded है पिछले थ्योरम से। Then further हम ये कह रहे हैं कि it attains its bounds on AB, yeah, at least once। The function may assume a value more than once, जैसे if it is many to one function, say x square, now x square attains 2 more than once at root 2 and minus root 2। मतलब ऐसे तो हम कह रहे हैं कि कम से कम एक बार तो इसको assume करेगा ही। Proof। Now if f is constant, then it's obvious, अगर f constant function हो वो change ही नहीं होती, इसका मतलब it attains a single value which is its lower bound as well as its upper bound, so there is nothing to prove। If f is constant, then f attains its bounds at every point। At every point। So, and there is nothing to prove। So there is nothing to prove. So we may assume that f is not constant। So let f be a continuous function on AB which is not constant, which is not a constant। Now, since f is continuous, previous theorem के हिसाब से, since f is continuous on AB, it is bounded there, means it is bounded above and bounded below। So अगर bounded है तो it must have a supremum and infimum। So let the small m and capital M be the supremum, yeah, be the infimum and supremum of f, yeah, this could define respectively of f on this interval AB। यानी वही जो मैं यहाँ इसको कह रहा था, exactly वही। So we have to show that there exists some numbers alpha beta belonging to AB such that f of alpha is equal to the small m and f of beta is equal to this capital M. Okay. Suppose that f does not, अब हमें दिखाना है ऐसा होना चाहिए, ठीक है ना? Suppose that is not the case. Suppose f does not attain, चलो for example हम लेते हैं, attain its supremum for some point, supremum m. So it implies that f of x is not equal to m for any x belonging to AB. Then it means that m minus f of x जो है cannot be equal to 0 for any x belonging to AB. तो हमें ये भी पता है कि इसका सुप्रीमम है, यानी f of x is less than equal to m, which means that m minus f of x is greater than equal to 0. लेकिन अब साथ में ये 0 नहीं हो सकता, तो इसका मतलब m minus f of x must be strictly positive, which means that m minus fx must be strictly positive for all x belonging to AB. Now consider this function. Consider this function. Let's create another function g defined on this interval AB to r given by g of x is equal to 1 by m minus f of x. अब जाहिर सी बात है ये कभी 0 नहीं होता, so therefore this is a continuous function. This is a quotient of two continuous functions where denominator does not vanish. Therefore g is a continuous function and it is continuous on AB because f is continuous on AB. This is a number constant minus a continuous function is a difference of two continuous functions, and constant divided by another continuous function is a quotient of two continuous functions on interval. Therefore it is a continuous function, and g of x is strictly positive because the denominator is strictly positive for all x belonging to A. ठीक है? अब but by previous theorem अगर कोई function continuous है तो it must be bounded. Gx is g is bounded on this interval AB. So implies that, so let k be the supremum of g. K be the supremum of g. It implies that g of x is less than equal to k for all x belonging to AB. Then chunki non-negative hai, k must be positive and 1 by m minus fx must be less than equal to k, which implies that इसको simplify करेंगे, we must have m minus fx must be greater than equal to 1 by k, which means that fx must be less than equal to m minus 1 by k. So for all x belonging to AB, okay, but this means that, this implies that m minus 1 by k, and you have to remember this k is positive. So m minus 1 by k is an upper bound of f on AB, and m minus 1 by k is strictly less than m, where this capital M is the supremum. ऐसा तो हो नहीं सकता, कोई भी अपर बाउंड जो है वो सुप्रीमम से छोटा नहीं हो सकता, क्योंकि सुप्रीमम सबसे छोटा अपर बाउंड होता है. So which is a contradiction. Therefore f of x, yeah, you must know. Therefore f attains its supremum on this interval AB. It may similarly be shown. It may similarly be shown that f attains its infimum infimum greatest lower bound on this interval AB. क्या हुआ इसको? पता नहीं क्या दब गया. कहाँ चला गया? Okay. But that I leave to you as a home assignment. तुम्हें इसी को follow करना है. Okay. So that was one part. तो हमने अब दिखाया कि अगर continuous है, it on a closed bounded interval, then it is not only continuous on there. It is least in the इस तरह से it is least upper, मतलब it attains its least upper bound. मेरे कहने का मतलब है, उसका मतलब हुआ कि range of fx, if it is a continuous function, it would be contained, and the range of fx would be contained inside this closed interval. Not only that, there would be some x's in the domain AB such that which are mapped to this small and capital. Now we want to do intermediate value theorem. एक और theorem है, लेकिन उसके लिए पहले थोड़ी तैयारी करते हैं, जो हम अभी करेंगे. कहाँ गया? Okay. वो ये है कि अगर कोई function है continuous, let me write it down as theorem. If a function f is continuous on at an interior point C of closed interval AB, and f of C is not equal to 0, then there exists some delta positive such that f of x has the same sign this is called sign preservation theorem as f of C for all x belonging to x minus delta x plus delta. कहने का मतलब, मान लो एक फंक्शन है जो कंटिन्यूअस है ऑन अ क्लोज इंटरवल AB. हम कह रहे हैं मान लो ये किसी इंटीरियर पॉइंट पे जीरो नहीं, मान लो पॉजिटिव, तो हम कह रहे हैं कि हम हमेशा एक इंटरवल ढूंढ सकते हैं विद इन दैट पॉइंट कि हर पॉइंट पे ये पॉजिटिव ही रहेगी, या अगर ये नेगेटिव है किसी पॉइंट पे तो हम उसके अराउंड एक इंटरवल ढूंढ सकते हैं कि उस इंटरवल पे फंक्शन जो है वो उसके वैल्यूज नेगेटिव ही आएंगे, पॉजिटिव ही आएंगे, मतलब इस तरह से. तो एक्चुअली ऑफ कोर्स इसका मतलब ये है कि जो कंटिन्यूअस फंक्शन वो जंप नहीं करती है ना, वो अचानक से पॉजिटिव से नेगेटिव में नहीं जाएगी. एक पॉजिटिव था फिर अचानक से इधर जंप किया, तो इट मस्ट हैव फर्स्ट कम क्लोजर टू द origin, and it must cross the x-axis. That means coming closer to 0, and then it must cross 0 to the other side. So it's obvious what, and that should be the case, but we will prove it. Okay, let's do the proof. Proof be simple है. Now since f is continuous, तुम इसके बाद फिर से ज्वाइन कर लेना, provided मेरा इसका ये नहीं चलेगा तो अभी 5-6 मिनट है तो ये बंद हो जाएगा, फिर तुम फिर से ज्वाइन कर लेना. Suppose f is continuous at C because it is continuous everywhere, तो C पे भी continuous है. So therefore जो continuity की ओरिजिनल डेफिनेशन है Therefore, for every epsilon positive, there would exist some delta positive such that f of x minus f of c in modulus is less than epsilon whenever, for all x belonging, whenever x minus c is less than this delta, right? So which means basically that f of x lies between f of c plus epsilon. I should have f of c minus epsilon whenever x lies between c minus delta, c plus delta. मतलब इसी को दूसरा तरह में लिखा इस तरह से. Now suppose f of c is positive. अब ये zero नहीं है, ये positive हो सकता है, negative हो सकता है. Now if f of c is positive, ठीक है, what we do, we choose an epsilon between, because f of c is positive, it's bigger than zero, so between any two numbers I can choose another number. So I can take this epsilon which is positive, right? Now this is true for every epsilon positive. So in particular, when I choose this epsilon smaller than f of c. So then what does that mean? So it means that f of c minus epsilon is positive. And what? अगर ये positive है, then f of x जो है, it is bigger than f of c minus epsilon, which is bigger than zero for all x belonging to x minus delta x plus delta. अगर f of c positive है, तो f of x भी positive है for values in this interval जो हम कर चुके हैं, यानी उसकी same sign है. अब हम दिखाएंगे अगर f of c negative है, तब भी ये true हो. So let's call this condition, यहाँ पे जो मैंने इसको लिखा है, इसको 1 लिखते हैं. Okay, तो क्योंकि मैं next page पे जा रहा हूँ. Okay, now in case f of c is negative, तो मुझे दिखाना है कि इंटरवल पे x की वैल्यू जो है f of x वो भी नेगेटिव हो, स्मॉल इंटरवल. So then I choose 0 less than epsilon less than minus f of c, because फिर minus f of c positive होगा, which means I can choose a number, a positive number between this two. मैंने वही किया. So therefore, so that तो हम देख सकते हैं इसका मतलब f of c plus epsilon should be negative and f of x by 1, f of x is less than f of c plus epsilon, which is negative for all x belonging to x minus delta x plus delta. That is, तो अगर fc नेगेटिव है तो इस इंटरवल में f of x भी नेगेटिव होगा, और of course अगर positive है तो positive होगा. So therefore f of x has the same sign as f of c if x belongs to x minus delta, c minus delta मैंने गलत लिखा है, c minus delta है, मैंने यहाँ पर भी तो यहाँ पर भी वही गलती है ना, c minus delta c plus delta, वो यहाँ पर भी एक्चुअली मैंने थ्योरम में ही ना लिखा है, सॉरी. तो यहाँ c minus delta, बाकी सब कुछ ठीक है, बस यहाँ पे लिखने में थोड़ा इसकी जगह c आ गया था. Anyway, but no issues. So we are done. So it should be c minus delta, c plus delta. That's what we have to do. So this is done. इसके बाद इसी को हम यूज करके, वैसे 1 मिनट रह गया है, क्या करें, मैं इसको काट दूं फिर तुम इसको कंटिन्यू करो. मैं इसको काटता हूं, तुम फिर से करो इसको, क्योंकि 1 मिनट के बाद फिर से करना पड़ेगा तो फर्क तो. मैं इसको क्लोज करता हूं और फिर तुम क्या करो, मैं इसको फिर रीजॉइन करूंगा.